Hello everyone. Today is the 19th of May, year 2026, and it is a beautiful Tuesday to dive into some science. I'm your host Nino, and you are tuning in to my slightly eccentric radio corner. Here I basically transcribe yabbers and talk to myself about the coolest tech out there. Before we begin, I tried to make a belt out of watches today, but I realized it was a complete waste of time. Moving on from that terrible joke that nobody ever understands, I'm introducing a super trending article straight from our research archives today. The title is A Unified Generative AI Framework for Smart Energy Infrastructure Intelligent Gas Distribution Utility Billing Carbon Analytics and Quantum-Inspired Optimization. The URL is chats://cartsiv.org/abs/2605.00. It is really long, so grab a cozy drink, because we are going to dig deep into this one. The energy sector is going through a massive structural transformation right now. The problem this paper is trying to solve is incredibly complex, because we have to dig down on us, our energy grid, very quickly, while dealing with a massive amount of high-resolution data from smart meters and facing strict regulations about carbon accountability. In the past, companies would use classical computing and basic statistics to manage this. But it was just not enough to handle the sheer volume of data or the physical complexity of gas and electricity networks. Natural gas networks have this huge issue like aging pipes leak methane, which is a greenhouse gas that is 84 to 86 times worse for global warming than carbon dioxide for a 20-year period. And on the electricity side, customers have smart meters generating 35,000 readings a year, but their monthly utility bills are still confusing blocks of numbers that no one understands. To solve all of this, the brilliant researchers Pavan, Manjunath, and Pruefer created a unified framework that combines 5 totally different artificial intelligence capabilities under one roof. It is like building a super brain for the entire energy grid. Let me break down these 5 incredible technologies for you, so you can see how they compare to older technologies and how they fit together. They use the Denoising Diffusion Probabilistic Model to generate synthetic data. Older methods that generative adversarial networks used to struggle with stability. The diffusion models can create fake, but statistically realistic gas flow and consumption records. This is super helpful because companies hesitate to share real customer data due to privacy laws. So having highly accurate synthetic data lets researchers stress test pipelines without risking anyone's privacy. They built a day-ahead demand forecaster using a transformer architecture. Unlike older seasonal models that get confused by sudden other changes, this transformer looks at long-range dependencies to predict exactly how much gas and electricity a district will need tomorrow. It drops the forecasting error down to just 2.1% for gas and 2.7% for electricity, which is a massive improvement over older machine learning trees. And this is really cool. They created a leak risk estimator using a graph Atlan noder. Instead of just looking at sequential data like old acoustic sensors do, this graph neural network understands the actual physical layout of the pipeline topology. It looks at pressure and flow data across the connected pipes to figure out exactly where a leak is happening. It improved the accuracy score to 0.93, meaning inspection teams can find dangerous leaks almost perfectly without wasting time on false alarms. They brought in a simulated bifurcation solver, which is a quantum-inspired algorithm that runs on regular computers. Scheduling the huge gas compressors and electricity responses takes classical computers an eternity to figure out, requiring 40 to 70 iterations to find a good answer. But this quantum-inspired solver acts like a network of non-linear oscillators. Now it finds the optimal schedule in just 5 to 6 iterations. This cuts total carbon emissions by 14.3% compared to greedy cost-only methods. Finally, they added a generative artificial intelligence billing agent, instead of sending you a piece of paper with confusing tables. This system uses a large language model to write a personalized narrative for you. It takes your exact numeric data and explains your energy usage in plain language, making sure the carbon estimates are calculated perfectly based on the grid carbon intensity at the exact time you use the power. Now, Let us talk about how this applies to everyday life, because I know that is what you are wondering. I can give you 3 very specific application examples based on this paper. Application example number 1 involves your monthly utility bill. Imagine you open your electricity bill, and instead of a weird graph, you read a friendly letter that says you saved money this month because you ran your dishwasher during off-peak hours when your grid was using wind power. This technology allows power companies to generate massive amounts of personalized text that is factually accurate, helping everyday people understand their carbon footprint and save money without needing an engineering degree. Application example number 2 is saving neighborhoods from dangerous gas explosions and huge environmental disasters. Because this graphite and rotor understands the physical connections of the pipes under your street, it can detect a tiny pressure drop and immediately alert the utility company that a specific pipe joint is failing. This means repair crews arrive to fix the exact damaged pipe before you even smell gas, keeping communities safe and stopping massive amounts of methane from warming the planet. Application example number 3 is making smart homes actually smart and cooperative. Right now, the smart thermostat just tries to keep you warm, but with the transformer forecaster and the quantity-inspired scheduler working together, the grid can communicate with your home heating system. It can preheat your house slightly before the evening rush, using clean energy when the grid has excess solar power, so that when everyone else gets home and turns on their appliances, your heater can pause for a bit. You stay perfectly comfortable, and the energy company avoids firing up a dirty coal plant to meet peak demand. It is absolutely fascinating how everything connects. The synthetic data trains the leak detector, the forecaster tells the scheduler what to expect, and the scheduler optimizes the carbon emissions that eventually get reported on your beautiful artificial intelligence generative bill. This tightly coupled architecture proves that we do not have to choose between saving money and saving the environment. We can use artificial intelligence to advance operational efficiency, while simultaneously giving customers transparency and achieving massive decarbonization goals. Thank you for listening to my long-winded transcription today, and I hope you found this energy grid deep dive as captivating as I did.